This conference will now be recorded.
Okay, so I think many of you were waiting for this session. I mean, on puzzles. We have this kind of session earlier too, and then many of you requested that we want to have one similar session again. That's why I thought of, okay, let me have it once again. Now, all the puzzles here which I mentioned will be different than what I have covered in the previous session. Now, first of all, why I am focusing too much on puzzles? I mean, it is supposed to be a big data course, right? Yeah, I know that. But the moment you try going for top product based companies, you name it Walmart, Amazon, Flipkart, right? Microsoft, whatever, all the big companies, if you try going in, they will ask you little bit on DS, and they can also ask you problem solving using this logical puzzles. Very, very important. Now that's why, as I say, my course is focused towards those directions. I try to give these things too so that you have some idea around it. Now let's start without delaying it much. I have framed four puzzles. Let's see how many we can cover. How it will go is that I will first of all tell the problem statement to you and will give you some time. You try to think of the answer and then you can tell the answers. And in the end, I will give you the right, most optimized solution. Fine. So the first question is a relatively easier one. Now they ask you, I give you 4 points. How can you keep these 4 points equidistant from each other? Is there a way you can keep these 4 points equidistant from each other? What figure will you get? I mean, if you want to answer, you can unmute yourself and tell your name and try to answer that.
Triangle. Sir, this is Vikas. Triangle.
In triangle, we have 3 points, not four.
Leave
It's
could be rectangle.
pyramid.
So the
It could
square,
be
sorry.
pyramid.
Yeah, it's pyramid.
Pyramid.
Okay. Anyone says square? Anyone?
Yes, square. This is Brahman.
Okay, Brahman, square is
Yes.
not the right answer. Sorry. So if anyone thinks of square, that's not the right answer. Few people said pyramid, that's the correct answer. See, in square, are all the 4 points equidistant from each other? No. I mean, square is, I mean, the opposite points like diagonal points. Don't you feel it's a different distance compared to other points? But when you talk about a pyramid, consider 3 points equidistant equilateral triangle, and then you can have the fourth point in the air at same distance from those points. So it's a pyramid, a 3D figure, not a 2D figure. In 2D figure, you cannot have this kind of thing. If someone says, no, no, sir, it is possible in 2D figure, you can let me know and we can talk around it. Anyone says, no, square is the correct answer? Brahmam, I think, are you clear? Hello?
Yes, Sumit.
Okay, okay. So the answer is not square. Remember this. It looks that okay, square 4 lines are there, same size, so 4 points are equidistant. No, that's not equidistant. If you see, the distance varies, but the correct answer is pyramid here. In pyramid, how it happens? It's like a triangle first of all, and the fourth point will be in the air at same distance from others. Now, this is a very interesting and one of my favorite problems. You will enjoy this, I'm sure. So consider you have 16 coins kept on a table. When I say coins, consider it like tokens. I mean, do not think that, okay, is it a 1 rupee coin, 5 rupee coin, 10 rupee? Does not matter. Think there are 16 tokens or 16 some coins kept on a table. Now, two people are playing the game. I need one person to play the game with me. I mean, who want to be that person? Anyone volunteer? Any volunteer among you? I mean, it's
I can
fine.
say
Whoever. Sorry, what's your name?
Subhashish. Subhashish.
Subhashish. Great. So two people are playing the game. One is Sumit and one is Subhashish. Subhashish. I do not want to misspell that. Subhashish. Fine, right, Subhashish? Okay. Now, how this game goes is, Subhashish, I say that you are my friend, you will take the first turn, and second turn I will take. Right? Now, how this goes,
Okay.
we can pick either one coin, two coins, three coins, or four coins. I mean, you have the option to pick from 1 to 4 any number of coins in one go. Let's say if I give you the turn, you might pick three coins because three is between 1 and 4. So either you can pick 1, 2, 3, or 4. So I'll just mention 1, 2, 3, or 4. These are the only option available for you. These coins are kept on a table and you can pick either one coin, two, three, or four, any number of it. Then once you pick these coins, I will get my turn and I have the same rules that either I can pick one coin, either I can pick two coins, or three coins, or four coins. Then your turn will come, then my turn will come. That means this is how it will be. First your turn, then my turn, then your turn, then my turn. And in the end, let's say three coins are left and I pick them three and nothing is left for you. That means I win. Whoever finishes the coins wins the game. So whoever finishes the coins wins the game. Now, since you are my friend, I give you the first turn. That means I say you start the game, no issues. But the rules go same for both of us. Now, you need to devise a winning strategy that you should be the last one to pick the coins. How will you approach this? I hope the question is clear.
Yes, Sumit.
Yeah. If you want to do a dry run for this, we can do that. Pick some coins just to give you an idea. Pick some coins. How
Three.
many coins you want to pick?
Three.
Three. Okay. How many are left now? 13.
13.
Correct? Now I will
Yes.
also pick three. How many are left for you?
10.
10. Now you pick something.
4.
How many you picked?
4.
4.
Yes.
Okay. How many are left now? 6. Correct? 6 are
6.
left.
Yeah.
I'll pick 1. How many are left for you? Now
Okay.
5.
5. Uh,
Now whatever you do, you lose, right?
yeah. Uh, if I take
Okay.
1, you can take entire 4. Yeah.
Correct. So now you understood the game. Now devise a winning strategy that I am giving you the first turn. You need to make sure you have to win this game every time, no matter what my move is. Others can also think. Or if
Uh,
anyone feels that they have the logic and want to do a dry run, we can.
uh, Starting point, I'm like I cannot think as of now, but I got this thing that if the second second last chance, if five coins are remaining, then that person will surely win.
What's your name? What's your
Fine.
name?
Meenakshi.
Yeah, yeah. That's correct, Meenakshi. I mean that is correct. That if you give five to other person, then you will surely win.
Yeah. So
So, Sumit, Ronald here.
for reaching out
Sorry, what's
till
your
five.
name?
Ronald here, Ronald.
Yeah, hi Ronald.
So, yeah, whoever choosing the first place, like they should go in 3, 7, 11, 15 mode actually. I mean, 3, if second person is choosing 1 or 2, like then the first person should choose 7, 11, 15, like that it should go.
Okay. So can we do a dry run if you have the logic? That means let's say you are the first person to pick.
Yeah, I choose 3,
Okay, how many are left? 13.
then 13. Yeah,
Okay, I'll pick 3.
yeah, then 1.
Okay, how many are left? 9, right? I will pick 4.
So, so if I pick 1, how much left?
Then I will pick all the 4 and win.
Okay.
Hi, Sumit. Karan here.
Oh, what's your name? Tarun?
Karan.
Karan. Hey,
Yeah,
Karan.
yeah. So I think it's like always the second person will win because
No,
he is
okay.
taking the
Always
water.
second person will win. Okay. Then you can be the second person. I will be the first. Is that okay?
Okay, we can try.
No, that I mean I am giving you an opportunity to win by giving you the first turn. I mean, how can it be the second person will win? I mean, so if I am the second person and winning, it does not mean second person will win. It's just about applying the right logic. As simple as that. I have given the first
So,
chance to you. You can always win the game if you want. Yeah.
Sumit, Amarandu here. So, logically, I think the last two moment, one like last two draws, the value should be greater than or equals to 5, less than 8.
Okay, I mean, this is hard to understand. I mean, if we can do a run, if you are built with your logic, let me know. We can play a game. That will be better because I think some of the kid is not liking this game. Can you mute yourself, please? Request would
Sumit,
be,
can we
please,
start with one?
can we
The
start
first
with
person.
one?
Yeah.
Okay.
So if
So what's
first
the logic?
person will,
Uh,
sorry.
why? I mean, have you devised the logic or just randomly one?
Yeah, I'm thinking like five. After five, like nine is the number. So if nine is the number, the other person can maximum choose four, and then it will be five. And after nine plus four, yeah, it will be
13.
13. Like plus
Okay.
five, it will be 13. So if first person will pick one, then option for other
Then,
person like maximum four. Like I don't know like it is correct or not, but I'm thinking in 5 terms.
okay.
So if
5, 5.
first person will choose one, then maximum other person can choose four, maximum four.
Okay.
Maybe then it will be yeah. So after
Can
16 it
we,
will be 15.
can we do a run? I mean, let's say you picked one, I also picked one.
Yeah. So then one. If like if I'll get till nine, if my turn is on nine,
Okay, you
I'll
want
pick
to be at
four.
9.
Right?
Okay, but how will you get to 9?
Yeah. If I am on nine, then I'll pick four. Then five. Yeah. So till
But
nine.
if you get 8 also, you pick
So
3.
again, if I'll get 13,
Right?
I will
Sumit,
get. I'll pick
hi
four.
Sumit.
Yeah.
Sumit,
Hi.
hello.
Hi Sumit, Rajkumar here.
Hey, Rajkumar.
Sumit, actually, we can take, for example, you are taking three. I am the second person. I am picking two. In case that in the second round you are picking four, I am picking one. That means, in terms of if whatever that one round, if we add both number, it should be equal to five. So then it will comes in terms of each round. For example, you are giving me the chance of three. So again you are taking one. So it in terms of five, if you are doing on every round, at the last round it will be leave with five.
So I understand all of this, but I mean, theoretically, it becomes hard to understand if we can do a dry run and you say
Sumit,
you
Yeah,
are
yeah,
ready to do it. Yeah.
yeah,
Sumit,
yeah.
Hi, Sumit.
Can you
uh,
can I give my number?
yeah.
Sorry.
Yeah,
Sumit,
can you give one number, Sumit?
Yeah.
Hello,
What's your
Can you
good
Sumit.
give
name?
me?
One by one, please. Oh, what's your good name?
Yeah,
I'm
Rajkumar.
Ria. Chara.
Yeah. Okay. Any one of you, please.
Sumit, we can
Rajkumar.
play. Ronald here. We can play. Shall I start?
Yeah.
One,
Okay. I pick 4.
four,
Now you also picked 4.
Yes, yes.
Okay, then definitely you will lose. So it will be how much is left now? 6 is left, right? I will pick 1. 5 is left for you now.
Yeah, 5 is then I pick 4, I won,
Sorry.
right?
I mean, if 5 is left for you, you pick 4. How will you win? I have 1.
No, no, no,
I
no.
will,
I mean, I said 1 first, then you told 4, right?
correct.
Then 5. I mean, then next I am telling again 4.
Hello,
Then
hello,
7 is
Sumit.
left, right?
Again, if
No,
you
no.
if you pick two, then you will win. If you pick after 11, if you pick two, you will surely win.
No,
Wait,
no,
wait. I think
total.
No,
let's.
After 11,
Sumit. Hello, I can
after
explain, Sumit.
reaching 11,
Okay, after 11, how much you want to pick?
if you- two,
One.
Okay, how much is left now? 9, right? For me.
9. Yeah.
Okay, I pick 4.
Then
Then how will you win?
No,
Sumit,
I can
Shantanu
explain.
here. Sorry.
Hello,
Uh,
Sumit. I can explain. If the first person chooses one, then whatever the maximum number the second person can choose is four. So if he chooses one, two, three, or four, whatever. So I have the first person has to choose such a number that the second person comes to 10. Like if I choose one, first person, I'm the first person. If the second person chooses two, though, so the number becomes 13. Then I choose three, so then the number comes to 10. Then the first person can choose whatever 1, 2, 3, and 4, and I can accordingly then bring him to 5. So whatever number then he chooses, I can win.
That is correct. Correct logic. So now, how will you generalize or how do you come to this number that 5, 10, 15? How did you come to this conclusion?
I figured out while you were playing with the first two people that if the first person chooses greater than one, then always the second person can win, because the maximum we can choose is four. So if I choose two, then you can choose four and bring me to 10.
I
So
understand. I understand. Whatever you are saying is absolutely 100% correct. Now,
yes,
this is one step that we understood this point that it has to be the first person should start with 1 and should give a multiples of 5 to other person. As simple as that,
yes,
right?
yes,
But
yes.
now, how do we get to know multiples of 5 if we want to generalize this?
Five and
Using mod operator.
No, no. So I will tell you how. See, I have two more
using
puzzles. I will try to tell that. Now we started with saying maximum you can pick 4. That's why we want to have one more than that, right? So one more than that is 5, and we want to always keep multiples of 5 for the other person so that always game is under your control. Now, if let's say I change the problem statement saying you can pick any number of coins from 1 to 5, then you would be giving others in the multiple of 6. So that if 6 is given in the end to that person, he picks something and then you will in the end win. I hope you can understand this, right?
yeah, yeah,
Right? So the logic is that if you really want to win, make sure you give one more than the multiple of the maximum number of coins we can take. In my case, I said maximum you can pick is 4. So give other in the multiple of 5. Multiple of 5. And if you do that, you will make sure you win. So if I give you the chance and the number of coins are 16 and you want to make it multiple of 5, you will pick one coin. So the number of coins remaining is 15. Now if other person picks whatever, right? So 6 from 16 you picked one and other is left with 15 multiple of 5. Now let let him pick any number of coins now. Let's say he picked 2. Then what you will do is you will pick 3 so that again you give 10 to that person. Your intention is that in every turn you make a multiple of 5 and give to that person so that towards the end it will become 5. And when you give 5 to the other person, whatever coins he picks, he can. But in the end, you will be the one finishing the game. So how I came to this conclusion that I have to give multiple of 5 because 4 was the maximum number I can pick. That's why one more than the maximum number. If let's say to generalize it, if I say you can pick from 1 to n, any number of coins. Then I would say multiple of n plus 1.
Yeah, Sumit, one question here. If he himself starts again, then
If he himself, in the sense, who? The one who has to win?
So
right,
the
like here you give other person chance to start the game. But
Correct.
if suppose you are yourself starting the game and giving other person multiple of five, then
Then I will win. Then I will
okay,
win, right?
okay.
Yeah. I hope this is clear. I mean, for those who cannot understand this, probably you can go through the recording, but this should be understandable. Ronald, I think you are clear now. Ronald?
yes, yes,
Yeah.
yes, yes.
s-
So
So
whoever starting
the
first is
person,
having advantage basically, right?
right,
Sorry?
right.
Whoever
Yeah,
starting the game first, they will be having advantage if they know the
correct. No,
strategy, right?
absolutely. Absolutely.
Yeah, yeah.
But let's say
Got it.
if I slightly tweak the problem, if I say we have 15 coins and this is a scenario, you can pick from 1 to 4. Then I mean the first person do not have a chance in that case, isn't it? Because he got a multiple of 5, what he can do now.
Yeah,
See the beauty of it. Even you have the first turn, but you are at a disadvantage now.
yes.
I hope we are clear. Okay. Now let's talk about another interesting problem. Now again, if you do not understand this, do not worry. This is not related to big data, and it does not mean if you cannot understand this, you cannot understand big data. I mean, these are two unrelated things. Fine. Now, fair coin toss. The problem statement goes this way. You have a biased coin. Biased coin. Can someone tell me what is a biased coin? What is the definition of a biased coin?
One which is having slightly towards one side, like
Correct. That
advantage.
means the probability of getting a head and tail is not the same. That means might be head comes more times than tails, or might be tail comes more times than head. Ideally, the probability of getting a head and tail is both zero point 0.5. I mean, if you do not know mathematics, fine, that's okay, do not worry, right? This is how it is. A biased coin is the one where the probability of getting a head and tail is not the same, right? It's more inclined towards either head or tail. So you have got such a coin which is biased, might be tail comes more times than heads, or might be head comes more times than tail. You do not know that. Now you need to do a fair coin toss using that. How will you do? That means if I say fair coin toss, let's say me and Ronald are playing a game and we toss it. Finally, the result we want is that both of us have equal probability of winning. It's not that he should have more chances of winning or I should have more chances. It should be equal chances.
One time you will toss for head and one time you will toss for tail. In that case, probability will be same for both.
How exactly?
So you will toss the coin two times.
How many times? Two times.
So one for head and one for tail.
No, but
Yes.
let's say me and
In that case,
someone.
probability will be same.
Let's say I toss it two times and both times I get head. Then what to do?
Can you toss it for 3 times and check
Then
for
it's
I will toss it three times.
yeah 3 times and see whether it's like which
Let's say if
probability is
all three times it comes head, then what will I do? I mean, the answer should be that you should tell the final that okay, anyhow, someone will win. Let's say if all three times I get head, then what should I do? Will I decide based on that?
okay.
So answer should, yeah.
So one person should take both sides is like say for example n number of times. 5 times one person should take head and the same person should take the tail 5 times. Then the sum should work.
No, no. I mean, how many times you want to toss it? This will be too many times, right? I mean, you have to follow the best possible approach. That means tossing the coin the least number of times and getting the answer.
If the number is prime number,
How will that help prime number in all?
so
Hello, sir. You are saying that coin is biased. So if I assume that the probability of head is suppose zero point 0.6, then
Okay, head.
probability of tail means P is zero point 0.6, which is I am considering is the probability of head. Then the probability of failure will be zero point 0.4. Now,
Failure,
if
no,
I
I will say probability of head and tail. So tail is
yeah,
let's say 0.6 and head is zero point 0.4. Okay. Because together
okay,
it should add to 1. Okay.
yeah. Then if I calculate the probable if I toss the coin two times, and if I evaluate the probability of head head or tail tail, we can't find anything. But if I
Okay.
find the probability of head tail or probability of tail head, then it will be
Correct.
equal. In that particular
Absolutely.
way, we can evaluate the fair coin.
Absolutely. See, probability of head tail will be what? Zero point 0.4 into zero point 0.6.
Point,
Correct?
yeah,
And
and
probability
tail
of tail
head is
head will
also
be zero point 0.6 into zero point 0.4, which will all be the same, like which will be equal to 0.24 and 0.24. Right? This is how it will be. And head and tail we can ignore. So how the game will go is we will say we will toss it two times. Now if we get head tail, Ronald wins. This is how it can be, right? And if we get tail head as the combination, then Sumit wins. And if we get head head or tail tail, we start again. Correct, Priya? Start
yes, sir.
over.
Yes, this is what I want to say. Yeah.
Correct. Absolutely correct. I mean, some of you might not be from mathematics, so cannot understand, should not be a problem. But Ronald, I think, can you understand because second name is yours? So let me ask you.
Yeah, this was I was about to say, but I didn't say it properly, I think. Yeah,
Oh, okay.
yeah,
Okay.
yeah, I understood.
Fine. Fine. Then let's go with the final problem of today. Again, this is an interesting problem. Consider there are 25 horses, right? Now you want to find the top three among those. Top three horses you want to find. Now, how it works is that you have a constraint that you have a five-lane track. Five-lane track. That means only five horses can run at a time. Only five horses can run at a time. Now, how many races you want to conduct? How many minimum races? Minimum races you want to conduct to find the top three, right? Because you cannot make all 25 of them run at a time. So you have to make only five horses run at a time. But the top three that you want should be the overall top three. That means if let's say you get a chance to make all 25 of them run at a time, whatever result you would have got, you want the same result. But your constraint is only five horses can run at a time. Now, how do you approach it? How many minimum races are required in order to get the top three?
Yeah, hi Sumit. I think the answer should be seven.
Okay, are you already aware of this problem?
Uh, Not the same one, but it's something like choosing something from the set of few items kind of.
Okay, answer is seven, but think it how. I mean, think how
Uh,
and explain it how it will work.
yeah. So the similar approach that I have in, so let's say we have a set of five horses. First, we have a first race for the set of five horses. So total races will be five, and from each race I think we take top three. So in this way we make sure that the top three horses will be there in the final output. So
So
it
if
might be
you,
possible like in the first
so just
set
a second.
all the three
So
fastest horse will be there.
sorry to interrupt. If
Hmm.
you make five groups and make them run, it will be five races. And if you take
Yeah,
top three, all the five races, it will be 15. You would require three races again. So 5 plus 3 is 8 races already. How is the answer
yeah. No,
7?
I think again. Can you write it down? It's something like it's based on the comparison something. So it should be something like, let's say, mm, yeah. Can you write that row?
Okay.
Sumit, this is Ankush. We will pick two of them from
Can
each
I
race.
request someone to be on mute? I hear a lot of background noise. Young Kush, go ahead.
So I was saying like we will pick two of them from each race.
No, but don't you feel
I
if
think
we pick two, so don't you feel if you pick only two, this person can be the third one? I mean, we might be missing on
yeah.
that, right?
Yeah, Sumit, I think, sorry, so the approach should be like what I said. If we take top three horses from each race, so let's say we have 1, 2, 3, 1, 2, 3, 1, 2, 3, kind of like that. Okay. Now I will race all the top horses from each set. Okay,
Okay.
so
So
it
we
should be
raise
one,
this
one,
one.
one, one. Yeah.
Okay.
So now here the comparison theory kind of like is something. If I want the third horses from the last set to be on top three, then the first should also be there because it's slower than the first and second.
Correct, correct. I think you are on the right track, but let me put it
Yeah.
properly because we are running short of time too. So this
Yeah.
is the race one, this is the race one, this is race two, race three, race four, and race five. Now we got to know in race one, this person is first, race two, I mean, this person is second, third, fourth, and fifth likewise. Now we will race all of the first together so that we get to know this person is overall first, let's say. This person came second in this race. I will mark it. Okay. Should I do that? Maybe beyond. Okay. So this person came, let's say, second. This person came third. Now, don't you feel if this is third, this person is slower? This might be fourth and this might be fifth. Do you really have to consider these two lanes? Because if this is fourth, these people are already slower than him, isn't it? Just think of it. So don't we feel this we can totally eliminate?
Uh, yeah, Sumit, I have answer, I think. Uh, should I
Yeah,
explain?
yeah.
So yeah, so after this first step, right? This is the six, right? These are total six races now already there.
Correct.
So now let's say if the first row comes first, then he is definitely overall first. So we got first out of our top three, right?
So this
So
person is
from
overall. Huh.
yeah, so first row, sorry, first column. This is the first, right? And the second column, first is second, right? If 49th row we see, first is first, then second is second, and third is third. So from the third column, we do not require the four. So we can eliminate from the third column all the four,
Okay,
right?
correct.
Yeah. And from the second column, if there is second, then there is only possibility for two from second column to be third. So we can eliminate 3, 4, and 5.
Correct.
And from the first one, right, we can eliminate 3. So here comes the 5. But we already know the first, so we can eliminate 49 first column there. So we have the final race between them, and whoever comes second and second from that will be second and third.
Correct. Absolutely fine. Absolutely fine. So this is how it goes. I mean, anyways, I'll be sharing the recording of this session for people who cannot understand. But again, do not get worried that I mean we didn't understand. I mean, it's okay if you can understand. If not, that's fine. And your answer is perfectly fine. So I think with this, we are done with the four problems that we intended to do. I hope you enjoyed the session, right? And let's meet in 5 minutes for the doubt clearing session. I mean, if you do not have any doubts, no need to join. Otherwise, you can join and ask the doubts that you have related to the course. So let's meet in 5 minutes. Thank you all for joining this session.
Thank you.